Hello and welcome to EPSC Design. So now today we have to know about how to read and understand the P&ID. So to understand the P&ID, first we have to understand who make the P&ID. So everybody knows we are getting the P&ID from the process department. So what process think while making the P&ID? They have some software to just put the name of the refinery and get the P&ID ready? No, they have to prepare as per the process requirement. How they use in the line, piping component, instrument items, line size, insulation and tracing, spec break, many other things are there in the P&ID. What is a process? We have a lot of process in the refinery. We have a gas plant. We are getting crude oils. Refinery plants are there. So working in oil and gas sectors is a process. Our life also is not one kind of a process. Daily we start from the morning and ends in the night. In between we just keep flowing and connecting with the equipments. We are just like a fluid which flow without a pipe and connect a lot of things. It means we are just traveling and we are flowing like from home to office and connect with the train, auto rickshaw, bus is our equipment which connect daily. If you take your personal life to engineering life, fluid also flow with the help of pipe and connect to the equipment. It means fluid should be transferred from equipment to equipment with the help of pipe and some of the piping component and the instrument on that line. Fluid changes from the equipment. Means if you have one equipment over here and you have one equipment over here, the line is connecting from one equipment to another equipment. It means whatever the process is going in this equipment, the fluid will go and travel from here and go into this equipment, and then again in this equipment the process will get changed, or whatever the equipment is this, the fluid will get converted and then the output will get a different thing. It means if you have like an air separator, okay, and you have one line with the water and is there in the air, so the air separator will use to remove the air. If you have a compressor, if you have a heat exchanger is used to convert the hot into cold and the cold into hot. So we have a pump, boiler, furnace, agitator and tank, etc. These are the equipments is used. P&ID is just a single line presentation diagram which give you the idea about all the components comes in the process line. What information we are getting from the P&ID? If you have one page of P&ID, so what information you are getting in the P&ID? So first you are getting the line number. If you have one line, so they have written some line number, okay, so one is the line number. In that line number, what things you are getting? You will get a unit code, you will get the line size, you get the fluid, you get the spec, and you get the insulation size too. And what information you are getting more in the P&ID? You will get the piping component, you will get the insulation and the tracing on the line, you will get the branch connection. If you have one line is over 10 inch and you will get over a 4 inch, so you have to check what branch connection I have to take. So you know the idea about like this is a 10 inch, so this will be a 4 inch, so I have to check out with the branch connection. You will get the instrument and the tag number. You will get the equipment naming. you will get the line continuation number, you will get a flow arrow. So this is all the things you will get in the P&ID. It's just a kind of the information. Now I just give you some examples from where you can make your own piping instrument diagram, because when we take a P&ID we just goes on and just read the P&ID and we just goes and we make the model, but we don't know what exactly process has think, why he have placed the valve, because we don't know exactly what process he have taken and what process is going on. We have to understand the process. So I am taking this example just to understand you what it's things, what the process persons thinks, to understand and why they use the piping components, instrument items and special items. So I just want to explain of these one of the examples. Now why I'm giving this piping instrumentation diagram, and you can also think the same as process person do, what the process person understanding when they do a P&ID. Same thing you can also understand. Take some example of process which you know in your daily life. In our daily life we use it to make a tea and we use to make a juice. This both items is a fluid, am I right? This is a fluid which you know. It will be a very good practice to try with your own idea, because you know the process of your product from raw material to a final output, because we know how to make a tea, am I right? Because this is our daily life product and we know of the process. So now you know what equipment you will be required, piping component where to place, how much pressure you require to travel the fluid one place to another place, and what will be the temperature need and instrument items, what will be your maintenance part, so where you require a drain and all. Because if you take this one example, or you can take your any example which you know the fluid, which you know the product, what you want to exactly, you can start with the raw material and you can end with your final output. Because tea is that product that you can know, that every person know what is the tea. If I give you an idea like, take, okay, you can start with one raw material and end with the final output, so what things comes in this between, so you can get the idea about the process, about how the making a P&ID, why the valve, where the valve we have to place, where you require the instrument item to place. Okay, this is the one which we say one example, this is the one equipment. So here I have to place my valve, am I right? Okay, now either here we have some pressure, so I have to place here one something like an instrument item, because I have to know what pressure exactly is going into this tank or this equipment. So I have to know what pressure is going, so I will place a one pressure over here. Why I am giving you this example? Because you have to understand, you have to know what process is going on. Okay, now this is some kind of legend sheets where you can get the idea about the line. Okay, electric tracing is there, steam condensate, you will get the instrument item symbols, you can get the pressure control measurements. Okay, and this is some of the equipment symbols you can get. Okay, here we have something like pumps and compressor. Okay, this is all the pumps and compressor symbols is there. This is the heat exchanger symbols are there. This is the tank, pressure and vessels. Okay, so there is a lot of things you can get in the legend sheets, and you can find more. You can find over here the wall symbols is there. Okay, so whatever the things you need, if you are not getting in the P&ID, so you can get the legend sheet and you can check out with the valve. Okay, now you can go to this also, you can go through in the legends. Now we can have one P&ID over here. Okay, so you can see this is a continuation number we have. Okay, so it means this sheet, this line number is coming from this sheet. Okay, and here you have some air vent or something. Okay, here you have a drain. Okay, so here this is our line number, and here you have some pressure items is connected over here. Now you can see here we have a valve, and then we have some symbols of instrument items. It means he from this part at the downside is a piping part, and the upper part will be the instrument part. Okay, so you have to just model till the wall. So now here you can see, you can just goes on the line what how much component is placed, because this line is going inside the equipment, and this is all the wall is placed because of the process requirement is there. That's why this all the wall is placed. Okay, and you can see here we have a control valve, or we have to check in the legend sheet what this symbol is means. So what is symbol exactly? Is a control valve is there or some other thing? Because you can see here this line is connecting to this instrument item, means this pressure it will get control. Okay, how much, so it automatically it will get operated over here. So now you can see again we have another some valves are there over here, the component is placed. This is also one of the instrument valve is placed over here, because this is all the instrument items, some of the things is placed. So this is a requirement is there from the process, so we have placed over here that the process has placed the valve over here. Okay, so you can see the another sheet. So you have again you have got line, the line is from the equipment is going outside. So what things is required? He places one drain over here, we have a spectacle line, and then the line goes here and goes and connect to the equipment. So it means it's like you have to understand just one line. You don't have to see a whole P&ID at a time, because it cannot be possible to read and understand the whole P&ID at once, because you have to understand one line. You have to just take one line, how it's traveling and connecting to the another equipment, because it will be very easy to you understand the things like how it will be, because you cannot understand the whole P&ID at once, because it cannot be possible. So try to understand why he placed drain over here, why he placed the spectacle blind over here. So you have to understand what components has placed in the line. Okay, so what this symbols is means, so you have to check out in the notes. This symbol is means that we have to keep from this point we have to keep this wall in a minimum dimension. So minimum dimension from where you can get from in the notes, you can go and you can check it out, like this star symbol, what it means in the star symbol. So it will be give the dimension, like minimum it should be 500 or 800 something. So you will get the dimension from where in the notes you can get. Okay, so here also is placed the symbol over here, so it means minimum distance we required. Okay, then you can get this this is a symbol is there, F is written, so it's most probably go to the flare or something. Okay, so you have to just understand the P&ID, just understand one line, because every time it will be the same. If you see this P&ID, okay, the line what in the line is there, the component is there, nothing different it will be. We have a component over here, we have a control valve over here, we have a component. See, here we have component, here we have component, here we have the component. Here what is here we have some instrument item is connected over here. Okay, so this line we have done the study. Okay, here also we have a control valve. Okay, here we have a reducer. Okay, now you just understand this one line, what thing is there, instrument item is connected, valve is there, control item is there, again control valve is there, and a reducer is there. If we go to the next sheet, there also the same thing in the line. See, you can see here the control valve is there. Okay, now you can see here the valve is there, Okay, now here what is that, we are getting the spec brake, because here we are getting a spec brake. It means the material is getting changed, that's why they have used a spec brake. So here you can see we have a valve. Now here that's you can see these two lines. Two lines, what is mean? There is a one, another dotted line means is a tracing line. Okay, so you have to just understand one line, every line it will be the same, or we have to just need a concept what will be the other line is saying to us. So we have to just understand what the line is saying, what was the information is there in the line. You can see the other page we have done. So here you are getting any component here? No, because the process or requirement is not there to put any component in this place. Now you can see here we have something like it should be instrument. See, this is the instrument items are connected. Okay, and some other things are there. I don't think so. So you can understand that we have three P&IDs. Okay, so this P&ID, what we understand, the same concept you have to use for the another P&ID. It means what concept you have used for previous, what experience what we have done previously in your project, the same concept is used to the another project also. The P&ID it will different, the concept, the looks of the P&ID it will different, but your understanding, your study, it will be remain the same, because it will not change. It's not software, every time it will get upgrade. You have to understand the valve is there, the valve is there, the valve will not get upgrade. Instrument item is there, so instrument item remain the same thing, but your understanding should be get changed. Okay, see all the P&ID, all three P&ID we have there, all the three P&ID, the concept of study is same. See, we have this also P&ID, things of study and everything is the same. Everything, line number you have there, you have a tracing is there, you will be the insulation is there, you have a flow arrow is there. What previously we have got this P&ID also the same thing, next P&ID also is the same thing. You just understand this is a two project, but the things are same, the understanding is same. You don't have to like I have worked on this previous project, so it not means like it should be remain the same P&ID it will use in another project also. No, but your study, what you have done previous, the study, same concept you have to use for another project also. So now this P&ID is there. Okay, the means once you understand of this, the idea how to understand the P&ID, you just take a one single line and understand what exactly a line say to us. And I have given the example of the tea, to try to take one any product, which one you know, which process you can know, you just make that, or you make one plant of your process, or you make one plant of your product which you know better idea. You can take you can make it apple juice, you can make a watermelon juice, whatever you require you can just take and you just try. So automatically you will know the what. So now this is just our personal examples you are using. The same thing just convert into engineering life and just understand the equipments like heat exchanger are there, air separator are there, column is there, reactor is there, furnace is there, knockout drum is there. So everything, every fluid is changing into the equipment. The pipe is just using for a fluid, and we need some components and instrument item to place on the equipment to operate the flow, to check the instrument pressure. Okay, my next topic will be on spike brake, insulation, tracing and manifold, and tie point. Thank you. Is there any something you can mail me on epsc.design@gmail.com. Thank you. Bye.